And thank you very much for joining to this presentation about AI agents graphs. Basically, you're going to move forward your development of AI applications thanks of graphs. Okay, we've got a lot of things to show you. Let's start. My name is Alex Soto. My Twitter is Alex Soto B. I'm a Red Hatter, Java champion, featured speaker, and also I'm the co-author of all these books. Don't worry, I will share with you the QR code for downloading these slides and also a QR code for downloading for free this book, which is covers some of the things that we're going to see today. So let's wait until the end. Basically, probably most of you have already noticed that most of the development nowadays with AI is Python. Okay. And I do not have anything against Python. Okay. It's great. It works. It's a good language. I know. But, well, yeah, there is this, this report where they say that Java is 40 times better for the planet than Python. It's more, it consumes less energy than Python. 40 times less energy. You can see it here. Okay, so that's one point of why using Java instead of Python might be a good idea, especially in the for the AI, right? Which is super CPU consuming, GPU consuming, and so on. There is another reason. I don't know if you ever started using Python. I did in the past. And seriously, the Python language is great, but for me, uh, the ecosystem is, you get it crazy all the time because it's like, okay, I need to download this dependency, and then you download the one dependency, but then you update it another dependency and everything stops working, or one project that worked with one version of Python, then you upgrade to a newer version of Python, and then this application stops working. There's no backward compatibility. So, I end up super crazy trying to make Python application work all the time. But there is also a third reason. Basically, big corporates uses Java after all. Okay, you can think about banks, insurances, airlines, so on. All of these big corporates uses Java, not Python. So you can think that enterprise developers uses Java, probably, not Python in the backend. Okay, so that's another reason of why use AI and Java, because it's something that you feel natural. Keep in mind one thing. Amazon created a framework named DGL, which is like for training and inferencing models in Java. And basically, they created because they noticed that most of the developers in Amazon feel more comfortable to embrace AI if they could use their favorite language, which was Java. Okay. So, what I mean with this is that Java and AI is a perfect match. And probably one of the most used project out there for integrating Java and AI models is LangChain4j. As you know, LangChain4j is a Java project that lets you connect to different kind of models, right? Different kind of inferencing systems to make this interaction between Java and AIs super smooth. You know that with LangChain4j, you can implement promptings, right? Simple promptings, template promptings, and so on. So prompting is something super important, and LangChain4j let you do it easily. As implements memory. You know that models are stateless by default, but sometimes, depending on our application, we need to have a state. For example, a chatbot. And for this reason, we need a memory. And LangChain4j provides this memory. Also provides integration with different kind of LLMs, as you seen in the previous slide: OpenAI, Gemini, Local AI, Pullman AI, Llama or Llama, sorry, and so on. Also, it also lets you implement agents. So you can use LangChain4j for implementing agents, of course. And also it provides you some RAG and data augmentation feature, right? So with LangChain4j, it's super easy to implement a RAG system. It has utilities for ingesting these documents, and also it has utilities for augmenting the request that you send to the model. So you can think that LangChain4j is like a REST client with steroids. Okay, so it's a REST client because after all these models are accessed using a REST API, but LangChain4j adds you all these extra features that you might need in your enterprise applications that they are not offered by the model. Just as a reminder, you can just create a chat language model with LangChain4j super easily. In this case, it's OpenAI. You do OpenAI chat model.builder. You pass the OpenAI API key, the model build, and you've got the model. Then to interact with this model, you've got the low-level API. But in this case, I'm just going to use the high-level API that it's provided by LangChain4j, which basically you define an interface. You set the system message here, return the capital of a given country, respond only to city, and also you're offering the the user message, which is like, okay, what is the message? What is the question that I want to resolve? Okay, and then it said here, you see, I put here a parameter, which is this parameter, and then I instantiated this interface using the AI services.create. This is an utility that is provided by LangChain4j, and basically it just creates a proxy of this interface. So now when I do trivia.question Japan, what it's doing under the covers is that LangChain4j is connecting to OpenAI, sending this as a system message, and as a user message is sending what is the capital of Japan. Okay, and then it just gives you the response. Probably nothing new, just as a reminder. Also, as I mentioned before, LangChain4j provides you memory. So what's happening if I need memory? I need to remember my previous interactions with the model. Also, it provides you this method, chat memory. You put here, in this case, I'm just putting a message Windows chat memory with max 10 messages. So I'm only remembering the last 10 messages and done. And also provides some integration with tooling, that function calling that the model can make a remote call to a function that you define it, so it can execute a method. In this case, as you can see, it's a tool that it's used for sending an email. So if the model thinks that needs to send an email for any reason because you said it in the prompting, then it's going to do a remote call to this method and will call this method. Okay. Again, also it has this content retriever, which basically lets you implement RAG, for example, especially for consuming the documents that were ingested at the start time. Okay, so this is LangChain4j. Probably most of you already have seen an example of LangChain4j in Java, but that's great. Now we're gonna start, building our application. We have no problem on building application. We can create a chatbot. We can create a RAG, right? So just a system where we provide all our corporate documents or I don't know, information about our workflows, right? And then we let the model to ingest. And when we do questions, we just go to this database of documents and say, hey, I've got a question. Can I cancel my booking, for example? And then you just find through all these documents and say, yes, you can cancel it or not, right? So this is a typical RAG example. Also, you're going to start playing with vector embeddings like semantic search, semantic cache, and so on. And yeah, the well-known sentiment analysis system, right? It's like, okay, someone sent me an email. I want to know if it has a positive or negative sentiment. And depending on this, I don't know. If it's a positive, then I said, oh, thank you very much. If it's negative, then maybe I just send it to the support team so they can figure out what's going on. Okay, that's great. Let me show you an example of this. In this case, it's a theme park bot. Okay, let me start here the the application Quarkus Dev. Basically, it's a Quarkus application that is using LangChain4j. You know, of course, LangChain4j works with Quarkus, with Spring Boot, or with plain vanilla Java. So no worries. In this case, I'm just using Quarkus, okay, for the sake of simplicity. Now, I've got here the application up and running, okay, and I'm just going to localhost 8080. Great. You see that it's a theme park. This is the map of the theme park, and you see here a lot of information. For example, the waiting times of all the rides. Here, say, okay, this ride is 42 minutes, this is 20 minutes, Flying Dream 0 minutes, Stampede 12 minutes, and so on. So you see that I've got a system that provides me the waiting times for all the rides. Then here I put it the documents that I ingested. So also this application is using RAG. Basically, I provided all documents with a description of each of the rides. You see that it says, for example, the minimum height is 110 centimeters, the minimum height is 140, and so on. So I provide information about this, about the rights. And also, I'm just providing a geolocation system that you said, okay, you are here, and I can ask questions like, what are the rides that are near me? Okay, because I'm just storing the geolocation of all the rides and where I am located, and then I can just ask questions. So you can see that this application is quite complex, but I'm only using one model and one AI service for doing everything. Let me show you that it works, right? For example, what is the minimum height for uncharted ride? I can just ask it this, and you see here in chapter right, it says that it's 110 centimeters, and then it says the minimum height to enter in chapter right is this. I can say what ride that can go if my height is 115, so I just can run it again. Okay, with the height of you can access Uncharted and Diablo. You see Uncharted is 110 and Diablo is 110 as well. Or even I can say, what are the rides that are near my position? So I'm just going to run it. And okay. And in a field you say, okay, the right that near your position is Stampede and Uncharted. You see Stampede and Uncharted. Great, right? It works. It's super nice application. You can just get the code from here. Okay, great. But it has some problems. First one, okay, this is me. Okay, and I sent a question. Right? It's like, okay, what is the minimum height for going to Stampede? Since I only have one AI service, what I'm putting here is all the information. I'm just getting, for example, I'm just putting information like, for example, the waiting times. Okay, I'm just putting the information that I think that might help me to solve the problem. Also, you can just add more tooling information, like for example the geolocation or the weather or the weather forecast, whatever, right? I put all these together, even though I don't know if I'm going to use this time or not, this information or not. But since I'm only using one AI service, I'm putting everything together because I need to provide all the information that I think that the model might find useful. So I'm asking about something about geolocation or something about the height or the minimum height for going to Stampede, right? But I'm also providing information of how to access the waiting times. I'm providing everything together. So everything goes, together. As I said, I just put in the request, the system prompt, the user prompt, possible useful text segments. So I'm just asking to the vectors database, hey, given this request, what documents do you think might be important to generate a response? And I just also put in there, even though maybe I don't need them, but this is how it works. And then also a lot of tools information, like, okay, I've got a tool for getting the waiting times. I've got the tool for getting the GPS location and so on. That's great. It works, as you've seen, but it has some problems. First of all, you're sending a lot of tokens to the model. So the more tokens you're sending, more expensive, and the model will go slower. Also, it can hallucinate, of course. Hallucination is something that is always on the table, but the more things you provide, okay, it's more, it can provide you an unwanted response or even having an unwanted behavior because after all, you're providing all the information, all the tools information, all the rec information, all the documents information, but the model will do its best. So maybe it gives you the correct answer, maybe not. Also, you've got here the testing, how you test one application, one AI service that can do a lot of things, right? Like getting the waiting times or getting the weather or, getting the minimal hike. Then finally, what happened if I'm using multiple models? Okay, this is the problems. There are some problems here. One possible solution is this one, which is saying, okay, I'm going to split my application and put it into different, right? Into different AI services. So this is one AI services, this is another AI service, another AI service, another AI service. Great. And we've got a router AI service which says, okay, what is the question about it? If the question is about it, the weather, then use this AI service. If it's about waiting times, use this AI service. And if it's about, I don't know, something related to documents that are ingested by a rack, then use this AI service. In this way, you're not sending information or boiler or noise to the model. So you probably will have something like this switch router LLM next prompt. So you're sending the prompt, and then the router LLM would say, okay, you get it a weather, so invoke the weather LLM. If it's about waiting times, then send this to the waiting times LLM or AI service. Okay, again, works, yes, but you've got some problems. You're growing the complexity, right? So now you're just, creating a lot of AI services, which is fine. The problem is what happens if you want to add another system. So another AI service. Okay, let's increase the switch and increase more the switch. What's happened also if it's not that simple? So here it's only a router, but what's happened if this service requires other services? So you're going to put here another switch, like here, another switch here, another switch here, another switch here. So what's happened if all these AI services are interconnected? Or what's happened if we've got a human interaction? What's happening if I say, okay, I'm just calling this and I call this, and then I need to wait for human interaction. I need to wait until the human resolves the question. And then I can continue, right? Suppose that I say, hey, I want to write an email, right? A response email of this, customer compliant. It complains about something. I can generate an email, but at the end, someone maybe needs to, you know, review and then say, okay, I reviewed this, do it another, change these things, right? So there's always some human interaction. Also, what's happening if I want to run this kind of request in parallel, or I want to persist what happened? For example, in this case, I have no persistence of anything. So one request goes here, then it goes here. But what's happening if I want to review later that this given question went from here to here? Things are not persistent. So I don't know how to do that. And the answer is LangGraph4j. Basically, LangGraph4j is a graph framework, right? That it works really well with this kind of complex scenarios where there are multiple paths, some of them interconnected, where we want to make things stateful, where with human interaction support, you can, for example, also persist the path, so you know all the time what happened, what was executed, what not executed. It also provides parallel execution, subgraphs, also streaming. But one of the great things about LangGraph4j is that it's integrated with LangChain4j. So basically, LangGraph provides you these graph capabilities to interconnect nodes, to have human interaction, and so on. And then you use LangChain4j to put the AI part into each of these nodes. Something really quick, okay? Some graph concepts that are important. This is a graph. You can see that there's nodes, and then there is loops back and down. And there is the start and the end nodes. There is some nodes. These nodes basically are executes or maybe executes functions or or logic, okay, and make changes usually. So for example, you send here a text, and then this node will do something with this text. Maybe sending it to an LLM saying, "Can you correct me or do a spell checker or whatever?" Right? But there is a change. Then there is the edges. The edges defines the flow. Define the flow between the nodes. So I've got a node, and then I want to move to another node. How? I mean that which nodes I can move from one node to another node. This is defined by ages. And these ages can be conditional or not. You can say, if you are older than 18, go to this node, else go to this other node. So, so the ages can also have nodes. And also, a graph has an state. Basically, the state is like a map where you store all the current state for this call into the graph. So in this case, I've got one key prompt, and the prompt is, the text of my prompting. Then I've got another variable named I, which in this case it's 19. And then here I've got the response. The response is a K that still has no value. It means that I have not produced yet the response during the graph execution. So this is an example. Now we will see it running. But the example here is, okay, I've got this, this graph. It says this conf is awesome and the I is 2. This is the input. Okay, this is the current state of the graph. Then I say, okay, what is the next step? This node, the node number one. The node number one doing two uppercase and stores the result into another key, name it message one. And since it executes a two uppercase, the value is this conf is awesome in uppercase. Then we'll go here, okay, here in this conditional, and we'll say, okay, the I is 2, so I move it here, and I just execute the node number 2, which basically is a surround with this, with the a star asterisk character. So you see here the message to now it has this conf, but surrounded by the given character, and that's done. That's the graph execution. So let me show you this example. It's this one. Here is the code, and this is how you define a graph. Okay, here I define the state. Remember that the state is, as I said, is like a hash map. So in LangGraph4j, you extend from agent state. There is some other high-level APIs for doing that. This is the low-level API. Then here I implement the methods. Remember that I said there is a to uppercase, so I'm just getting the state. In the state, I'm getting the query, and then I store in this state a new message one with the query dot to uppercase. Remember that this is what we said it here, right? You see, message one to uppercase. Okay, now the same with surround, and the same, and here also the condition to surround. So here I'm saying, oh, if it's if it's this condition is true, then return star. If not, return plus. Why I'm saying this here? Because now you'll see how I put this condition into the graph definition. And basically here, you see I'm defining this conditional graph, where I'm saying this is the start graph and goes to node one. The node one then executes to uppercase method, which is this one. Then the node 2 executes the surround with this, and the node 3 executes the surround with the plus. And then I add a conditional age. And I say, look, when I'm moving to node 1, when the source ID is node 1, and then when I'm just going out to from node 1, execute the condition to surround, which is this one. And I said, okay, if it's a star, then move to node 2. And if it's a plus, then move to node 3. As you can see here, this is the node 2 and the node 3. And the node 2 executes the surround with the star, and the node 3 with the plus. Okay, now that's what I do. And then you return this compiled graph, and then you execute it super easily like here. Okay, you can see it here where I'm just getting the, I get the started state, which is query I is an everything in the map, and then I execute here the condition, the graph. Okay. Now let me go here and let me execute it. Here, Quarkus dep. Okay. Then I've got here, and I'm going here to the conditional. I'm going to put a trade out. I put here, for example, a number 2, and this conf is awesome. I send it, and you see that it just goes through all this map and returns this. Okay, now that's fine. As I mentioned it before, the example it's here. You can also implement, as I mentioned it before, human interaction. So here in this case, I'm saying, okay, I want to stop. So when I'm coming from the surrounding, before sending the result, I want to stop and ask a person to make a change. For example, saying, hey, look, I want to change with using the menus. So it will wait, and then a human could just change the state of the graph and continue the execution. Okay. Now, can you add the AI part? Yes. For example, we could use this demo. Basically, here it's like, we get it an email in our customer support, and we want to check if we can provide automatic answers to this email. Basically, you say, okay, this is the AI, and I'm asking, hey, categorize me the email of feedback, question, and so on. Then, depending on the category, can you provide an automatic response? Maybe yes, so we draft a response, or maybe not. And then here we open a wide range of possibilities. For example, going to search in web, or for example, wait for a human interaction, and so on. In any case, if we find the answer, then we can draft a response. We can just ask the AI to draft a response with the given information. Then the next thing we need to provide is, hey, is this email addressing the original email? So we are addressing the original question. Maybe it's yes, maybe it's not. If it's not, then it's analyze how to improve and improve it. And if it's well enough, then send it. And I implemented this again here, as you can see as an example. Here, I'm going to go here, advance it. Oops, sorry. Here, okay, this is again, Arcus dep. This is the application. It's started. Where is the, okay, now I cannot find the great. Why? Wait a second. I don't know why happened that, well, wait. Happening here in the bottom. Sorry about that. I don't know why this is happening. Okay, now, bum, 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 bum. Show AI here. And I've got, for example, feedback. I've got an example with the feedback. Basically, it's saying, hey, I enjoyed so much the stay, right? Then you see here that it says, I categorize the mail as customer feedback. Needs notice draft an email because it's just, it's saying something like, hey, we enjoyed a really good time. So I'm just, jumping directly to draft the email. Now, here in the mail, you see, thank you very much for your kind work. We're thrilled to was wonderful, blah, 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 blah. Then we still have 1 minute. Here in the question, here I'm asking a question. It's like, hey, I want to go to here to to, to your to your resort. What is the weather in April? So you see that now we need to go to do a web search and say, okay, thank you very much, blah, blah, blah. Typically is sun and so on. So you can see that the graph execution just goes through one graph or another, depending on the flow. Okay, now here Basically, some people ask if this is an agent or not. The agent should be only one AI service that does everything. Other things that what needs to be autonomous is all the system. My point here is that please just do what your enterprise, your corporates need. Okay, then basically AI is just the cherry part, right, of your sundae. Never stop training. And this is the slide. You can scan this QR code and you'll get these slides. And finally here, if you scan this, you can download it for free. The Applied AI for Enterprise Java Development book. Thank you very much.